Hi, Susanne.
Well, hello, Alan.
How are you?
Well, doing quite well today.
Yeah,
And you?
I'm fine. It's great to have you here. So, today my guest is Susanne Heipcke. She's Director of Software Engineering at FICO, leading the modeling and APIs team of FICO Express development that is also in charge of CI/CD, performance testing, and delivery infrastructure. Susanne's work covers all aspects of modeling, including her contributions to the development of the algebraic modeling and programming language Xpress Mosel, the book Applications of Optimization with Xpress-MP, and a number of research papers. With more than 30 years of experience in applied OR, she has also carried out or contributed to a number of consulting projects for companies in various locations worldwide, including scheduling and planning problems in manufacturing, personal staffing, aircraft routing with maintenance planning, portfolio optimization, trading, planning and unit commitment for energy producers, and retail logistics. Susanne regularly organizes specialist training events and sessions or streams at OR conferences. She's also a member of the European Practitioners Forum Committee, leading the organization committee of the forum's annual meetings in 2020, 2023, and 2026. Susanne, thank you so much for accepting the invitation. Looking forward to having a great conversation with you. So, Susanne, where do you come from in Germany?
Well, I've been born in the Ruhrgebiet, which is an industrial region in Western Germany, close to Düsseldorf and Cologne.
Mm-hmm. And what did your parents do for a living?
Well, my parents, both have been at university. My mother was a teacher, and my father held a degree in business studies and was working in administration.
And are you an only child, or do you have any siblings?
I've got a younger brother
Younger brother,
who
okay.
is still living in Germany.
And how was life while you were growing up? What did you do to spend your time?
Well, not many really interesting things, I would say. But I like reading, and I also like music, playing music, and also listening to music. And then, also some other, let's say, crafts and experimenting with techniques.
And yeah, and you know, music is one of my favorite topics. So, what instrument did you play?
Well, I play flute and piano.
Do you still play the piano or flute?
Very occasionally. So, it's just matter of time, really. I like playing, but I don't really have much time for it anymore, unfortunately.
Right. So, did you play classical music?
Well, I guess my preference goes to 18th, 19th centuries composers, but for piano also more recently also like contemporary composers like Johann Hisaishi or Jan Tiersen.
And what did you like to listen to in those days, in addition to classical music and 19th and 20th century composers?
Well, being younger, I was really more classically oriented, and I've read this a bit more as an adult also. Again, more contemporary music. Well, I still like opera quite a bit, and then traditional songs.
Did you play in any music groups?
Well, I've been playing in the school orchestra, for instance, and also there, while doing this even as an exam topic for my final high school exams.
Uh-huh. And what did you like to read in your younger years?
Well, I quite like historical novels, and in particular, reading in different languages about authors in their original language as much as possible. And then, I also enjoy reading humoristic or satirical authors.
Uh-huh. You studied at a girls' high school. Looking back, do you think that experience had any direct influence on what came next in your life?
Well, as I mentioned a bit already, I'm interested in mathematics, but I also have an interest in languages. And I've been wondering now, looking back, whether the being on a girls' high school actually has made it easier by this choice of going into mathematics, as opposed to perhaps being in a more traditional role where I might have gone towards languages as a subject of study. But that's of course completely hypothetical.
Right. I was going to ask you about your favorite subjects in school, but I think you already mentioned mathematics and languages. But tell me which languages you studied in those days.
Well, I mean, I've started learning languages at school, and then I also did some evening courses. So I mean, I've been well at school. I did of course English, French, Spanish, and then evening classes, Russian and Italian. And yeah, I mean, I really enjoy this, and I mean, I like also to be able to be in countries and talk with people in their own language.
But were you learning all those languages at the same time?
Basically, yes.
Wow.
No, I mean, it started one or the other, obviously, but yes.
Yeah, but it sounds crazy. It's incredible that you could manage to study all of those languages simultaneously. You even participated in a linguistics Olympiad, didn't you?
Yes, so in Germany there is a national competition. It's a bit like the Math Olympics that is more internationally known, but in Germany there's also a competition for languages. And I made it in my final year at school. I made it into the finalist round on national level. So that's a competition. I mean, at that time, I think rules have slightly changed in the meantime. But I mean, you start with recording. I mean, we're talking about the 80s, so recording on a tape, some some free speaking towards the subject. And then a second phase was some written exams. You had to go to a local university, which was already a challenge because, I mean, at the time, of course, I was at high school. So going to a university was was a new thing. And then the third round was writing some homework. I think it was 6 weeks towards it, literally or literature or political or society theme. And then the final round was a discussion group in different languages, translating to each other, really.
Do you feel you take on a different persona when speaking each particular language?
Well, yes, I think I do adopt a bit a different style depending on the language I'm talking. I mean, there is, one thing is, for instance, when you're talking English, there are no politeness forms, but many European languages have forms, like in German, you have du or sie, or French, you have tu, vous. So you make a difference in how you address yourself to people, and even having grown up in a certain culture, I mean, I would be incapable, I mean, as using a non-polite form to somebody whom I recognize as my senior or superior in some sense.
Yeah, for example, in Spanish, at times you might say tú, but then usted could be the more
Exactly,
appropriate
yeah, the
term. But
same system in Spanish, yes.
yeah, right. Do you have any specific strategy to learn languages?
Well, I'm just curious about, well, first of all, it's a bit the understanding, I mean, how a language works. So actually more the grammatical things, and I mean, just the structure to understand it. But of course, I mean, you don't get around learning vocabulary. I mean, that's just, if you want to be able to understand something, you just need to get the words and know them. So, but
Yes.
for me, it's a cultural thing. So what I like about learning languages is having teachers of the different culture who bring across not just what they not just language itself, but their entire behavior, which is also an important piece of information really about different language.
Mm-hmm. Yeah, you know some Spanish, French, Italian. It's time to learn a bit of Portuguese, I think.
I haven't got around to it, but I mean, knowing Spanish, I mean, I'm able to read it.
Yeah. So it seems that you learn how to program while still in high school. How did that happen?
Well, I was lucky in a sense that when it was, I think, 10th years at school, the school bought their first set of computers. And then, of course, the teachers had to learn what to do with these machines and how to teach computer science because, of course, there was no precedence and little guidance. I'm talking about the mid-80s about how to do courses in computer science. So I was actually part of a pilot group where the teachers were experimenting, and then it was introduced as a subject the year afterwards. But so I got the good thing about it. So doing it and having teachers discovering pieces, but not being marked for it. And so it's really the enthusiasm of the teachers. I mean, it was in portions on their free time because they just wanted to learn about this. And then because it was not a proper subject yet.
Yeah. You immediately fell in love with programming.
Well, actually, when this started off, I mean, I was quite hesitating to do this at all. And my father encouraged me at the time just to join the group and try it out. And then I discovered, well, it's not just something for geeks, but it's actually something, this structured thinking, it's something I just can work with very well. And it's actually something that I can do. And I'm really interested in.
Mm-hmm. Which language did you learn?
Well, at school, we were taught Pascal.
Pascal. Uh-huh.
And I mean, one needs to know, of course, I'm talking about the 80s. So this is just a screen, so a DOS environment. And I mean, no windows, nothing fancy, no colors, just black and white.
or black and green, depending on. Yeah. Did you have a computer at home?
I didn't have a computer. I only got a computer later on during my studies.
Why did you move to Bavaria to study mathematics?
Well, I was looking for a university that was small because as a second subject, I was doing business studies. And most of the large universities had business studies courses with more than 1,000 students in the initial year. And so it's very impersonal. I was looking for a university that would offer a smaller group. And so we are sitting there with 70, 80 people in business studies, which made it actually possible for me to work with a professor in business studies for my first year at university. And that was kind of exceptional. It's certainly not possible in other universities.
Right. And why did you decide to study mathematics instead of languages?
Well, then actually it was a very conscious choice because I went to inform myself, and then I mean, what can I do afterwards, and what is the outcome? I mean, yes, it's languages, interesting studies, but what can I do with this, and can I make a living out of this? And that seemed really more difficult with this, so I decided to go for mathematics.
Mm-hmm. So it was not a difficult choice in the end for you?
No, it was really quite obvious.
And how did you manage to pay for your expenses?
Well, it was actually mainly financed by my parents, but I was also suggested out of my school final exams. The school suggested me for some national stipend, and so I had a bursary from a national organization. The stipend included mainly additional funding, such as meetings of students of the society, or they funded also language courses abroad and things like this.
Right. I mean, so you had a scholarship.
You need to know that in Germany there are no fees for universities. So
Yeah.
But easier than in Anglo-Saxon countries.
Right. So you had a scholarship. So that helps.
Yes.
Yeah, sure. And so let's talk about the projects you participated in at that time. The first one involved data processing and resulted in your first ever publication, correct?
Yes, exactly. So as we mentioned, I mean, I was lucky that I got a student job working for a professor in business studies from my first term onwards, and there I had this experience from school in programming, and the professor was particularly looking for somebody who could help with the evaluation and handling of data for research project. And the project was about workers' contentment. The first one, or the first year, was in Austrian luxury hotellery, and a second one actually in a German DIY supermarket chain.
Uh-huh. That resulted in a publication, but it was not a journal publication, right?
No, it was in the specialist magazine of this hotel association.
And how did it feel?
Well, I mean, it was kind of incredible. I mean, just being at the beginning of my studies, and then also for the second project, actually, I was allowed to actually take part in the final presentation. And I was standing up, just a second year student, in front of 300 managers, and presenting about the work and the outcomes of the project.
Uh-huh. But were you introduced to OR at that stage?
No, I mean, this was really about data analysis, handling data, I mean, statistics, even one, but very basic statistics, really just averages, some correlations, but that was not really my part. So I was more the data handling person in there. No, so the OR I came across OR really by chance, I would say. I mean, I mentioned earlier that I had a stipend from a national organization, and they were organizing regular, or still are organizing regular meetings about for the students in mathematics and computer science. And there I started talking to somebody working for BASF, so a big German chemical company, who was looking for somebody to do an internship with them. And so I said, well, yes, I don't have any experience, but I want to do my master thesis in applied mathematics. And so I just got into this without any prior knowledge, really. And I convinced the professor at my university to accept my master work. But he told me from the outset, I can't help you. And so I had really to do the master work by and large, learning about this while going along. I had, of course, the team at BASF who were specialists in optimization, operations research to help me, and also who had a lot of background knowledge. But the challenge was actually for my diploma, and also then later for my Ph.D. thesis that was also funded by the same team, that they wanted to learn about constraint programming. First problem, at the time, this was not called constraint programming. There was no fixed term. We're talking about early 90s. There was no fixed term yet for this new set of techniques. So were you searching for something? Well, internet search was very limited still at the time. If you don't know the search term, it is, of course, even more complicated. And so they had heard about this, and so they had a tool at hand that they wanted to evaluate on some of their problems. And so they asked me, well, do something with this and implement this. So this was a specific constraint programming tool implemented in Smalltalk. So there I had to use to learn a new language also just for implementing this.
Small talk.
One exotic one, yes.
I've never heard of
So
it. Small talk.
well, it's an object-oriented language, and rather unusual for this set of tasks. I think it's more used for graphical and purposes. But I mean, there was a tool, and somebody had implemented and a constraint solver.
Uh-huh. So that project led to your master's thesis, and what was the application exactly?
Well, I've been working on several scheduling problems at BASF. One was the resource planning problem, so scheduling jobs and then on machines, of course. So that's sequential in machines, so chemical reactors, and then also with staffing resources. And a job running had not a flat usage profile, but actually different steps of loading a machine or then just some surveillance or then unloading had different, so a stepwise profile of usage. And I mean, putting such a resource constraint problem into application. So that was one of my master thesis examples. And the second one was actually scheduling jobs on a high performance cluster at this group, because they had they were not just doing OR, but more generally scientific computing. And they're also scheduling jobs. So that was the second application.
Yeah, and at that time, using constraint programming to solve discrete optimization problems was really a new thing. I believe the literature was rather scarce. How did you acquire the necessary knowledge to solve those problems using constraint programming?
Actually, for the first year, I had quite a hard time. I mean, I didn't really get on at all because the person, I mean, I had something written up in German, and then I translated this into constraint nets instead of constraint networks for the, but due to some closeness of German terms in English. And I mean, there was the term constraint programming didn't really exist yet. And so I really couldn't find much at this because I didn't know which community to look for. And then after 1 year, I did a first presentation at the German Conference for Artificial Intelligence. And there then people finally met some people who actually put me onto the right track, while here, there are publications or new articles and look at this. And well, I got more contacts at that time.
Yeah, I can imagine how difficult it was. It was a sort of a prior to the internet boom, and you really had to work hard to get access to all of that material. And regarding your team, were there any female representation, or it was sort of in balance? Do you remember?
Well, actually, I was very lucky with this work team, which was actually quite exceptional in the sense that it was led by a female mathematician, Dr. Anna Schreik. And I mean, she is really well, let's say a very interesting person. As I mean, she had started building up this team of mathematicians in the 80s. And it is quite rare. And I mean, even afterwards, I mean, I've been in contact and remained in contact with several members of this team. And well, it was probably, yes, I mean, there were more male than female colleagues, definitely, as always in mathematics. But when there were several other women around also. And so that was, in a sense, quite exceptional in this community.
Right. Was she an inspiration for you?
Oh, definitely. I mean, that's really a way, I mean, about how she led and yeah, her way of interacting with people in a very calm manner. And also, I mean, the fact that the team at BASF was then willing to finance my PhD, I mean, sending me to universities abroad, taking me into their research projects. So, I mean, I've been really helped quite a lot by this, by the confidence that people had into me as well, being able to figure out things, learn about something they didn't know, and actually to teach them about these new techniques of constraint programming.
Mm-hmm. Yeah, that's excellent. And what happened after you graduated in 1995?
Well, as I said, I mean, BASF, they financed my master, and then, well, I did my master thesis work with them and took my exams, but they were prepared to finance my PhD. So still, while working on my master, I went with one of the colleagues from BASF to see different universities, to see who would be willing to accept me as a PhD student. Now, complication here was from BASF side. They didn't want to finance a research program for several years. So they were looking for a university where I would be able to work on their problems immediately and not take classes for 2 or 3 years. And so this reduced this. I mean, and we went to see a couple of universities in the US and also in Germany, and also in the European projects. I was a member of Lawrence Wolsey from CORE also. I mean, and then it ended up being a choice that I went to Buckingham University in the UK. My PhD supervisor was one of the owners and founders of Dash Optimization, so the company doing the Xpress software at the time. And at Buckingham, there was no formal program in terms of taught courses for PhD, so I could just immediately work on this. Now, of course, there is a problem. I had to learn certain things. And so this is why BASF decided to send me, first of all, for half a year to MIT, to the Aurora Center at MIT, and there take classes and get more of the basics, also meet some people and well, just discover a bit about more broader about operations research.
And was it your first time in the US?
Yes, that was my first visit to the US.
What were your impressions at the time?
The funny thing is actually that while I was in the US, I started feeling European as opposed to being German. And so, because I felt a bit of the cultural difference between, so that I found it easier to understand people with European background or even people from other cultures, including people from India, actually, who have a long-standing history in their countries. And yeah, so that's really this international experience.
Yeah, and also being at MIT, I think it was also something really.
Oh yes, definitely. I mean, it's it's almost a world apart. I mean, it is not being in the US, but it's more you're really in this academic on-campus life, and it's not just being anywhere in the US.
Mm-hmm. So after your period at MIT, as you mentioned, you went to the UK. And how was it adapting to a new country?
Well, I ended up actually quite liking being in the UK, except for the weather. And Buckingham is a very small town. Well, it's an old university. No, it's not an old university, but it's a very old town. The university was only funded in the 70s, if I'm not mistaken. But the town itself has very old buildings. It's very traditional. And so it's by and large in the countryside, halfway between Oxford and Cambridge, so a bit north of London.
Yeah, so we're in between these legendary places. When you think about academic
And actually funded
studies.
by, really the founders were people mainly from Oxford, who actually wanted to do something new. So it was born out of the 60s movement, but people coming from the traditional universities.
Mm-hmm. So in your PhD, you combine mixed integer programming and constraint programming to solve production planning and scheduling problems. Could you elaborate on that?
Well, as I've been saying, I mean, I've been working on implementing problems with constraint programming tools, and particularly the early constraint programming tools were completely discrete, for solving discrete problems, and completely lacking the bounds, so the dual information, of course. So yes, you could find solutions, but then you have no idea of how good they are. And the idea was really to use constraint programming as the propagation, mainly as pre-processing in nodes of the branch and bound tree, or also as heuristics to find start solutions for mixed integer programming. At that time, pre-solving and pre-treatment techniques in mixed integer solvers were not yet very developed. Later on in the 2000s, standard commercial solvers have adopted much more the ideas of propagation and local sort heuristics and all these things, but this didn't exist in the 90s.
Mm-hmm. You mentioned that you use Smalltalk to code constraint programming models. And in your PhD, what tools or languages did you use?
Well, I mean, my Smalltalk, this was for my master thesis, and it was really not so practical because the solver I was working with had a C interface. And so, I mean, I switched over to for both my master and my PhD, I've been working with Xpress. And I switched over to using an academic tool called Shadens by Yves Colombani from the University of Marseille. And that was a small solver academic tool, but in the form of a C library, and that I could easily use. Many other constraint programming tools actually at that time came out of the Prolog world, which is yet a very different way of formulating problems.
Mm-hmm.
But I was more familiar with C at the time, so that was much easier for me.
So the integration between MIP and constraint programming came through callbacks?
Yes, I mean, that was one of the important features, actually. Xpress had published in the early mid-90s as the first commercial solver, a callback interface, so that actually no longer treating a solver as a black box, I started and wait for it to come back, but actually being able to interact with the solver via cuts and by jumping into each individual node of the branch and bound tree to be able to interact, do something, this something in this case being triggering some propagation in a constraint solver and exchange information between the two cuts, or then bound information, improved bounds in particular, then being passed back to the MIP solver.
Right. And what path did you take after concluding your PhD in 1998?
Well, at BASF, I was part of some EU-funded research projects. And as such, I mean, there were participants, Dutch with Xpress as a software company, but also various university partners. I've already mentioned Lawrence Wolsey at Core. He was always a member of these projects by BASF, and then a couple of other universities in varying combinations, some other companies also taking part. And then in the course of one of these projects, actually, I switched over from being on the BASF side to being on the software side. So I moved over to Dash, really. So. And I mean, I continued. This was in the final stages of my PhD, and then I really continued doing almost the same things, actually at Dash. One of my tools that I had developed for my thesis work has actually been productized and has become something that is now known under the name of Xpress BCL. So that has become part of the Xpress product suite.
That's very cool. And why did you move to France in 99?
Well, I met my husband, and he moved to the UK for some time, but he is from France, and at some point we decided, well, living further south is more pleasant, and so we decided to move to France. Well, it was possible by EU laws in the late 90s to work from a different country for a company in an EU country. But actually, nobody knew which were the right forms to fill in for this. So it was a bit of a challenge figuring this out. It took us some time. But we have been working from France ever since. So for more than 25 years now, working remotely. So really being forwarders on this aspect, really.
Yeah, I was going to ask you, how did you manage to work from home in an era before Zoom, Git, and similar tools existed?
One needs a certain discipline, of course. So I mean, it's we set up means of doing local backups first of all, and whenever we went back to the seat of the company, we of course we took over the sources, and well, we already had internet, of course, so we always worked via email, and then well, you didn't have video calls, you just had plain phone calls, but that was sufficient actually to coordinate the research work. And then one does need regular face-to-face meetings. And even nowadays, in the area of conference calls, I'm still in favor of being able to meet people in person from time to time.
Right. And how did you handle maternity and work?
Well, being at home made things quite a bit easier, really. So I have 3 children. By now, they're all young adults. And well, yes, it takes some organization, but because both of us were at home. And then there is a very well-organized childcare system in France, but that is also an aspect that made it easier, for instance, as it would have been in Germany at the same time. Have somebody take the children somewhere, particularly when they were small, somebody who looks after them during the day, and being free to do your work and not trying to duplicate yourself and to do work, look after children, which, well, is not easy. And of course, because we were at home, if there was any need, children sick or something like this, then it was possible to sort this out.
Yes. And how did your kids react to the fact that you guys were working from home?
Well, they've never known anything else, so they always knew we were working, and from very small on, I mean, we made them understand, I mean, there is an office, and that's a place where they are not supposed to be, and I mean, they've just grown up with this.
Uh-huh. And so let's talk about your extensive involvement with Mosel. Why don't you start by telling me the story behind its name?
Well, it's not really a story. So first of all, I mean, Mosel is a language, and a language for formulating, an algebraic language for formulating optimization problems. But at the same time, we introduced the concept of having a program language. So not just the declarative specification of problems as what would have been the case with its predecessor in the Xpress suite, that was called MP model, or some other languages that were already around at the same time also, like AMPL. So that's a full programming language, which was a new concept at the time. So something like callbacks that we have mentioned earlier were supported from the outset in this language. And we were working in EU-funded projects where we also had other partners, in particular constraint programming vendor, which was Cositech as a partner doing the software chip. And so the language was developed for algebraic modeling, but with the possibility to extend its syntax to covering completely different ways of specifying problems. And then also not just specifying problems, but also solving them, iterating, interacting during the solve via callbacks with the different solvers. And so the story behind the name is really we've mainly been looking for something that would be easy to pronounce and similarly pronounced in a reasonably large set of European languages. So, yes, we've been playing around with something like modeling or solving, but didn't really come to anything. And then at some point, we just decided, it's this one. And that has been the name ever since. Mosel is the name of a German river. So it turned out it was not such a good choice for a software, because if you look for it, you come about the things about the river, the geographical region, lots of wine. And then there are also a number of German software projects that also use the same name for other types of software. But that's just a bit anecdotic. So.
Yeah. Yes. Also, thanks for providing the context. That's very important. So the viewers and listeners that are not familiar with Mosel, they now of course know some of its background. And you started contributing to Mosel around 98, 99, but the software was only officially launched in 2001, right?
Yes. So, this was a development within a EU-funded research project. And we started development work. So first of all, there was already an existing algebraic modeling language for Xpress. So first step was provide the proof we can be compatible, we can do the same thing, and at least at the same speed as the existing system. But that was completely internal, nothing new, but we can take the existing system and move this onto a completely new architecture, because the new language actually has its own virtual machine. It compiles models in terms of just parsing them. And so compiles model just like what Java would do to its own virtual machine, meaning the compiled code is, this binary form of a model is platform independent. So you can just develop in Windows, let's say, and deploy it on a Linux cloud nowadays.
Mm-hmm.
That's quite important. So there's a completely new architecture behind this, with these new concepts of being not just a modeling language, but also the solving programming part, and then by proving really that we can do this. And so this was the really the work of the first 3 years. Plus, then within this research project, also long discussions about what such a new language should look like. And having industrial partners involved, having people from universities involved, there were quite strong opinions about how people want to write models. And then we also did something like a guide. It is still referenced actually on ResearchGate. So it's like a guidebook how to write certain scheduling problems. And there again, that was then using the language. But how should we formulate this? And using very short names for variables, so the mathematical style, or using long names for variables. And you can have really long discussions about this, what works better. Yeah, so it was really a consensus development between different partners and what people would feel comfortable with using.
And how was the initial reception from the community?
I think it was quite well received, really. So Mosel was first presented at the Informs annual meeting in 2001 in Miami. And so it was a really new concept at the time. And but people adopted it. And of course, we provided conversion tools and ways of switching over, as I said, also running the old style models. But it was actually quite quickly adopted by customers and by users of existing modeling tools.
Mm-hmm. And Susanne, could you walk us through the evolution of Mosel over the years, highlighting the development of its main features?
Yeah, the basic concepts were really already present in the, let's say, in the very basic version. So the idea of modeling and solving and extensibility, to have an open architecture that actually makes it possible to connect anything that is present in the form of a callable C library as new functionality into the language. Now, that was something that was already present in the very first version. Well, this first version had, in terms of mathematical concepts, well, mainly the features for stating algebraic problems, focusing at the time on mixed integer programming. But straight from the beginning in this EU-funded projects, we also had a module for stating constraint programming problems. This one was not commercialized, but used, and then we later on switched to a different partner, Artemis, who now contributes the constraint solver Callis into the solver suite that is supported through Mosel. But yes, I mean, in principle, you can connect any type of solver into this language. And I mean, we show on public yet a number of examples, just really how to connect them up. Yeah, so that was the first version. Second version, building out on data structures. So we introduced data structures, record and lists. So really the more programming type evolutions. Later on, we added more nonlinear solver support. So that was another piece. So the solver side, of course, not. I mean, this was done by a different team, but efficient handling of nonlinear expressions, even the possibility to have derivatives calculated. And then also very early on, I think about 2008, must have been version 3 of Mosel, starting to think about parallelism on the modeling level. So first of all, being concurrent on the same machine, so same processor, and then little later in a remote setting. And this functionality of Mosel then being able to invoke the software remotely, so from a platform that doesn't even have a full Xpress installation, for instance, being able to invoke and remotely control execution of Mosel models. And then also if I am in my piece of Mosel code, starting distributed processes, completely controlling this. That's a major piece of work, actually, to be able to do this across networks of different types, I mean, Windows or Linux platforms. Based on this functionality, then Xpress has released, I think around 2012, a new software called Xpress Insight, which is let's say, one level up. So we have the solvers at the node level, modeling tools on top of this, and then third level, which is the graphical tools for deploying and hiding away, in a sense, the mathematical model to end users who really just want to see some tables, some input fields, and nice reports about what is the solution and what to do really in a production environment. And so that's a web-based environment and completely relying on all these remote computing functionalities, remote launching of Mosel. Yeah, and ever since we have been mainly working on more programming features. So once we had the let's say this environment of having a graphical interface on top, we've been working more and more on programming features because people were starting to use this for very large projects. And large meaning complicated setups. So you have models, you have submodels, you have subproblems, you have interesting forms of input, giving users all different ways of configuring things. One big tool based on Mosel is called Decision Optimizer, which is a tool that pre-existed at FICO. So I should perhaps mention that in 2008, Dash Optimization has been acquired by FICO, so we had become part of a much larger company. And so Decision Optimizer existed. It was a tool written in Java. And then the team I was part of at the time has taken charge of this and completely re-implemented this from scratch based on Mosel and Xpress Insight. So because in Mosel, we had the possibilities of handling very large expressions. We had the data handling present, and we had the software stack for deployment on through Xpress Insight. And I mean, that's still a very large project and being continued, relying on all these various functionalities. But then as soon as people use this software for programming tasks, new requests come up and ideas of what one could do. And we have been building this out.
Fascinating. Thank you so much for making this description of the evolution of Mosel. Very, very interesting. And is it true that the team behind Mosel is still the same of its early days?
Yes, exactly. So the main developer, Yves Kounoubani, and myself, I mean, we have been on this project, and for me, it is really a red thread through my activities, because I've been doing some of these development, testing, documentation, writing examples, and more the tasks about more the, let's say, the communication tasks and the customer-facing things. And Yves is more on the side of really doing the implementation, inventing the software in a sense. Well, for me, it is red thread in the sense that I've had lots of other activities also. I've done some consulting projects. I'm involved in marketing tasks. I'm in organizing conferences and so on. So it's not my only task, but it has gone over all the time. It is quite exceptional in terms of software development. Over such a long time to have really a continuity, the same team developing this. Well, there are different components that are in charge of other colleagues and who have been contributing, usually also on a longer time period basis, really.
Yeah, and establishing and maintaining communication is crucial, right? I mean, for this longevity, I suppose.
Oh, definitely. I mean, it is, having a person who knows things have been done and they have been done this way because whatever is the history behind something is, of course, helps. And then so you can have the continuity and the logic behind this, and also the initial version. I mean, we had lots of ideas, but some of them from the initial version, they were only realized in version 4 of Mosel, so 10 years later. But I mean, we had the ideas of things what we could do or wanted to do from the beginning. It was just, of course, a matter of priorities and deciding on what to do at what time for a software that, of course, needs to be acceptable to the public. And it's not just writing the software itself. You need to be able to bring it to the customers, explain it, and maintain documentation and all these things.
Right. And Mosel is currently on version 6, but it's still highly compatible with code written for version 1, isn't it?
Yes, so of course, we have introduced some new concepts, and usually we have tried to be really incremental. I mean, there have been some changes that were breaking changes, but we have really tried to keep them at a minimum level. And so that in the book, Applications of Optimization, that was written for version 1, most of the examples, actually, you take them and you just run them without any changes.
Yeah, that's remarkable, actually. And the software became free since 2018, correct?
Yes, so we have turned Mosel into free software, but closed source. So we have certain components, and many of the newer components, they are completely open source. Many of them reside on Git, on public repository. But add-on tools like Mosel testing, which is our own testing system that we're just publishing, or Mosel Doc, so the online documentation out of source code. So add-on pieces, and also certain modules. So some of them because they rely on public libraries, others because we actually want to show how to do this. So for instance, the interfacing to other mathematical solvers, I mean, there are examples on the on GitHub also just showing how to do this. And since we made this free software, we are really encouraging the community to go off and use this language and connect up other pieces. And I would be really happy to see contributions at this point.
Right. And what are your favorite contributions to the software?
Well, different pieces. It's first of all the design. So the initial design, or also say, there is a new feature, and as a user, I want to use it this way. Then the collaboration with the developers to see, well, yes, I want it to look this way, but is this feasible with my efficient ways of implementing this. And it's often, like for more advanced features, it is actually going back and forth, finding the right forms, finding efficient implementations, then also the experimenting. If I have a large constraint expression or something, then what is a typical way of using a software, and then Mosel has evolved over time, in particular its data handling pieces have evolved based on what we see from customer usage of the software, aligning the behavior of the software, or have the software do, in a sense, some guesses of what users are most likely to do with things, or how they are most likely to use this. This refers to a large extent to the handling of sparse data structures. So if you have an array, well, in a textbook representation for a linear problem, you have a matrix that has coefficients. It's a square matrix. But in realistic settings, the software is usually most of the square are just zeros, and you don't want to pass them on. And then the idea of algebraic modeling languages is actually to have clever ways of handling this case, and making this work fast. And so this needs customer data, so real life experiences with what are people doing with this. And so this interaction with user is something that I really quite like. And we also have this specifics for Xpress that is always the developers, for me on the modeling side, but also the solver developers who talk directly with the customers. Because it's a two-way process. I mean, we learn what people are doing or what they want to do, and where possibly difficulties arise. And then also we can teach users to, well, this is how we have designed it. So this is how you do this efficiently, what you want to do with the software.
Yes. And in a way, you ended up working with languages in your professional life. It's not in terms of linguistics, it's a modeling language. But I think you mentioned a lot about communication, interacting with your team, customers, and coming up with something clear. And I think it reflects your many talents, and especially this thing of connecting math, computer programs, OR, and languages. Do you think it makes sense?
Yeah, I mean, to a certain extent, yes. I like talking about the work I'm doing, and I like teaching, so it's quite an important aspect. So I mean, for the first version of Mosel, for a couple of years, I've been teaching a course on modeling at the University Aix-Marseille. And I mean, also still sometimes I do courses at universities. And I do training courses, so it's not just about holding training courses, but actually designing the courses. So what is the contents? What do we need to talk about? What do we want to teach people, or which modules to offer? And so that's an important part of my work, really. Also then, or on the individual support level or consulting projects, really understanding the business context and then putting this back first into math and then actually into a model and experiment with how to do this really for large scale problems to make this work well. And
Yeah,
that's certainly an important part of my work, yes.
yeah, that's very nice to hear. And how do you see the relevance and the necessity of conducting research on the software engineering aspects of optimization?
Mm, well, I have mentioned in the beginning that Mosel is a language that has its own virtual machine and produces compiled code for this virtual machine. Now, there are basic choices that have been made, but well, of course, certain things can be revised. Others are just, I mean, that's basic design concepts that once they have been made, we cannot go back on them unless we just rewrite everything. So yes, there is a need for having decent training on software design. So that is more the computer scientist's perspective. But then also as a mathematician, there's a need for understanding complexity. So you cannot just take blindly a textbook model and throw it at whichever solver or whichever modeling tool. There's a good chance that it's actually not going to scale. And so I mentioned this topic of sparse data. So how to handle realistic data and realistic, extremely large data sets. And there is there are many aspects to think about. And I was actually lucky at my university. I mean, I mentioned we had mathematics and business studies, but actually mathematics professor insisted on having a decent computer science. So not just programming courses, but also some courses on data structures and complexity, which as mathematicians at the time, we thought, man, that's not mathematics, so we're not this interested in this. But looking back at this, it's a very important piece then for the actual work I'm doing nowadays, understanding these topics really.
But still on this aspect of software engineering, at times when we do research, we want to do the code as efficient as possible, and we're comparing the results with other research groups and trying to beat them. But at times the code can be not really clear, and if someone comes later on and try to maintain it or changing something, it's very difficult. To what extent do you think it's worth sacrificing efficiency for the sake of having a code that is easier to work and understand?
Yeah, for a piece of software that has been around for 25 years, and if you take the whole of Xpress now for more than 40 years, proper software engineering and proper structuring of development processes is really crucial. Otherwise, over time, for the 40 years of Express, none of the original developers is present nowadays. So there is a handing over process happening from time to time, and new people come with new ideas. And the software development just needs to be properly structured, properly documented. Otherwise, a larger team cannot work together on a piece of software. So having procedures in place, there are different aspects to this. It's having proper procedures for testing, being able to go back to older versions for performance comparisons internally, and also being able to rebuild versions. So as a software company, it is not just the current version, but we also need to provide patches for certain older versions to our customers. So we need proper systems behind this, and procedures in place, need to come to agreements about how to write code and how to manage all these things. And that's to a large extent, these systems are also part of certain members of my team are in charge of systems, but it's of course all developers that need to adhere to standards and work with these tools.
Do you contribute to the code of Mosel or Express?
Very little, I must say. So I'm more, for modeling, I'm more on the user side, let's say. For the modeling language, I'm on the user side for the solvers. And I'm also more using Mosel as a language. I'm contributing to certain of its components, yes, to add on tools like Mosel Doc, for instance, but little to the core itself. So I've been more always on the evaluation and design, evaluation, and then explaining side of how to use it or how best to use it.
What's your take on the recent advances of AI and its implications on the development of optimization software?
Well, I've been in touch with AI through constraint programming for a very long time. So AI is now kind of a hype word, but it has been around for a very long time. For optimization solvers, many of the ideas that are now common practice in commercial solvers come out of interactions or exchanges of ideas with the AI community. So it's really not new to optimization solvers to use AI techniques like local search, for instance. Of course, now this is much more publicly visible. So, of course, we have at recent conferences, members of the Express team have been talking about, use of AI techniques. A couple of years ago, this was more machine learning, but nowadays it's often LLMs and Gen AI. But these are just aspects of AI, and there's much more to it, really. So yes, it's important to have these interaction. As I said, interaction has been going back and forth for a long time, not just these last few years. And it is important to be aware of what is happening and be open to see and use new techniques. And of course, don't miss out on anything that seems important to or could become important.
You mentioned LLMs and all these advances in recent years. How do you see that this can affect the development of modern modeling languages?
But the languages as such, perhaps not so much. It is more the usage or how people start getting into something. So what we have been presenting for Xpress at recent conferences is the use of Gen AI tools to support the onboarding of users. So actually as intelligent help systems to start working with software on different levels. So the modeling software or also then guidance through inside up. So really on the up level, if you haven't looked at some interface or at a screen or sets of screens for a few months, you've probably forgotten what was the workflow or something. So have intelligent tools that actually help you through this entire process.
So, Susanne, you have been very active when it comes to organizing conferences, workshops, and special sessions regarding optimization software. What can you share about this?
Well, I'm a big believer in communication and in bringing the right people together. And that's, of course, a driver of organizing conferences and going to meetings myself, but then also, having reached a certain degree of visibility, I can extend invitations and organize streams or organize meetings. For the particularly for the Euro Practitioners Forum, we have we are groups of people organizing conferences, meetings between practitioners in OR who exchange quite freely. And the organizers are almost all working at companies, either consulting companies or companies using and working with OR. And so really the exchange between practitioners, but completely on a voluntary level. So everybody contributing, but because we're interested in talking to each other, hearing about what other people are doing, other companies are doing. And this is on this external conferences level, but I'm also organizing quite a few internal trainings and onboarding new colleagues and mentoring. So it's also a bit of aspect of giving back. So I've been helped at my start and passing this on and helping younger people to get started in their working lives.
Yeah, very nice. And some of these initiatives have been organized in collaboration with Bob Fuhrer from Ample, right?
Yes, exactly. So I've been in recent years, we have been co-organizing the modeling software stream at the Informs annual meetings. Yeah.
Yes. I met Bob for the first time in Santiago at the IFRS conference, and then I met you last year in Copenhagen and again this year in Leeds. So it was very nice. And you're also an active member of the Europe Practitioners Forum, formerly known as the Europe Working Group on Practice of OR. Could you comment on your involvement in this initiative?
Well, I've been organizing conferences now. That's the in the COVID year, and then a second version of it, physical presence, then a couple of years later, and now upcoming next year, a meeting at Warsaw University. I've been lucky to be able to put together or to form teams of people, practitioners in OR, who are engaging on a completely voluntary basis to organize meetings, and because they want to hear from other people and they are willing to share their own experiences. And so that's a very lively forum of people in OR and people not just, but really mainly non-academic people, really who are willing to exchange not just about the OR problems, but actually also the practical issues behind. So, how do you put into place an optimization application with all the impact and the political questions or whatever else can happen at companies, really?
Yeah, that's a very important initiative. I feel that this helps reducing the gap between theory and practice. And for the youngsters, this is just very, very valuable. And Susanne, do you have any regrets?
Not really. I mean, I've been able to choose in many places to moving to France, for instance, and then decide, well, I'm working from home. So no, I mean, I've been able to realize many of the things I wanted to do.
Right. And what do you have in mind for the future?
Well, I hope I can continue working. As I said, I mean, I'm quite satisfied with the things I have achieved, I have done. So I would like to continue. I mean, the development of Mosel, of course, it's not done. I mean, we still have lots of ideas. Well, I'm involved in many other activities, initiatives, so be it really directly work related at FICO or something like the practitioners forum. I like the diversity. So yes, I have this thread of Mosel development, but I like challenges. I like doing new things, and well, experimenting, meeting new people, and experimenting new ideas. But at the same time, still, I mean, always keeping in this modeling environment, really.
Uh-huh. And any final thoughts for our young viewers and listeners?
Well, I would like to encourage careers that are non-standard. So, well, people who have unusual experiences. And, well, of course, you need, if you want to be in software, you need to have a programming background. Yeah, for the main solver business, I mean, we really, you need to have a C programming background. That's one of the prerequisites, really. But I mean, really, I have been at universities, at two small universities for my master and for my PhD that are not very well known. But I have made conscious choices to be there, and so really encourage careers that are different. So actually, that a CV has something that well distinguishes it from others.
Yes, that's great advice. Susanne, it was great to having this conversation with you. I'm so happy. You were a role model and trailblazer. You've done a lot of interesting things technically, and also all your initiative to improve communication regarding optimization software. So thank you so much, really.
Yeah, you're welcome.
Yeah. So I wish you all the best and take care of your health. And looking forward to meeting you soon one of these days.
Yeah, thank you, Anand.
Okay. Bye. Ciao.
Bye.